we discussed about the altitudes of the triangle, okay? And now medians. See, median, the name itself is suggesting median, mid. So median is just corresponds to the mid of the side, any side of the triangle. So for suppose initially if I have a triangle ABC, and for this BC, if you locate, if you identify the midpoint as some D, okay, what it is? The midpoint of BC. If D is the midpoint of BC, and if you join A to this D is known as median. So here from the diagram, AD is median of the vertex A. So at the end, what is median? Median is simply the line joining the vertex to the midpoint of opposite side is called median. Once again I am repeating you, median of a vertex is the line segment joining vertex to the midpoint of opposite side. So this is the vertex and this D is the midpoint of BC. This joining of this line segment is mentioned as the median of A, and we usually name it as like AD. Okay? And as per these notations, M1, M2, M3, this median length is M1. And now we are going to find that length, okay? Right. This median length is M1. In the last class, we represented those altitude lengths as P1, P2, P3, and we derived certain rules for that P1, P2, P3 in terms of delta and ABC. Now here, now we are going to find the rules for this M1, M2, M3. Okay, this is median. And since there are three vertices in a triangle, just look there, we have three vertices, right? So A, B, C. Since we have three vertices, so three medians are possible in a triangle. This is median through A, which meets the opposite side of BC at the midpoint, and this is median through B, which meets the opposite side AC at the midpoint E, and this is the median through C, okay, which meets the opposite side AB at the midpoint. So there are three medians in a triangle, and those three medians will for sure meet at a point, and that point of concurrency is mentioned as the centroid of the triangle. Okay, this point of concurrency is denoted by G, and it is known as centroid of triangle. Once again, median is the line segment joining vertex to the midpoint. Since there are three medians in a triangle, those three medians will concurrent at a point, and that point of concurrency is the centroid. And now if you look, this centroid is a point which is there on every median, right? Because it is the point of concurrency, for sure it is there on every median. So it is there on median AD, it is there on median BE, as well as it is there on median CF. So for suppose if you take a median and a centroid on it, for suppose if this is the vertex A and AD is the median, on this median somewhere for sure there is centroid, okay, and this is D. Yeah, and now see, with certain properties of plane geometry, we can easily show that this centroid divides this median always in the ratio 2:1. So if this part is 2, this is 1. So AG by GB is equals to 2/1, 2:1. Not only the median passing through A, centroid also divides the median passing through B and median passing through C also in the same ratio 2:1. Once again I am repeating you, centroid is the point of concurrency of the medians, and so it is there on each and every median. And if you analyze, if you observe the ratio, how it divides the median. If you observe the ratio AZ by ZD, that ratio is 2:1. Centroid divides every median. There are three medians, so it divides every median because it is there on every median. So it divides every median in the ratio 2:1. That two parts is from the vertex side, and that one part is from the side part. Okay, so this is 2 and this is 1. So sometimes you may face certain problems. If the length of this GD, centroid to the midpoint of the opposite side D, if the distance from ZD is some 5 units, then what to say about the distance from vertex A to the centroid? So since it is in 2:1 ratio, if this length is 5, then that length is 10, 2 times of the 5. So this is the simple definitions related to the medians as well as the centroid. Just have a look and then I will discuss the next point. Have a screenshot. Just look there, B bit related to the medians and midpoints based on the areas. For suppose we have a triangle ABC and AD is the median. Since AD is the median, this BD and this DC both are equal, right? Because D is the midpoint. If you wish to calculate the area of this left triangle and that right triangle, for this triangle, the area is half base into height. So this is the base. And for this triangle, this is the base. These two are equal. Bases are equal. Half base into height. Half is also equal. When coming to the height, for these two triangles, height in the sense distance from the opposite vertex A to the side BC, which is also same. So it is very clear that the areas of these two triangles are same. Okay, that's what you need to identify. If you have a median in the triangle, then that median divides the triangle into two equal areas, two triangles of equal areas. These two areas are same. That's one part. Okay, and the next part, I have a triangle. And in this I have a triangle and just I am naming the triangle as ABC. And in this triangle somewhere I will locate centroid. Okay. So I will construct three medians and I will locate the point of concurrency of the three medians and we name it as the centroid G. And if you just join this centroid to vertex A, to vertex B, to vertex C. Okay, centroid joining to the three vertices will give us three triangles and these three triangles have equal areas. Okay, median and centroid. Just have a look. Okay, right. And one more thing. I have a triangle. I am not giving you the proofs here. Okay, just I am mentioning the statements from the plane geometry. Yeah, the triangle is ABC, and this D is the midpoint of BC. Okay, and then E is the midpoint of AC, and then F is the midpoint of AB. Now if you join these three, what will happen? If you join these three midpoints, what will happen? Okay, just have a look once again. Yeah, then in this case, the areas of these four triangles are equal. Okay, all these four triangles have equal areas. Just have a look. In the first diagram, I just constructed one median which divides the triangle into two smaller triangles of equal areas. In the second diagram, I am just identifying the centroid and this centroid will divide the total triangle into three small triangles. Everything has the same area. And here you just locate the midpoints of the sides and if you join them, you will get four triangles and those four triangles are of equal areas. So midpoints of the sides will divide the triangle into four smaller triangles of equal areas. Centroid will divide the triangle into three smaller triangles of equal areas. Median will divide the triangle into two smaller triangles of equal areas, and everything you need to identify. Okay, and our concentration is basically on medians, so use for some time just leave about the midpoints. Okay, and this is one idea which helps you to calculating the what areas, and usually they may ask you some questions. I will give you one problem related to this. Yeah, if area of triangle DEF if area of triangle DEF is equals to 6, then what you say about the area of triangle GAB? Okay, right, just think about it. Area of triangle DEF is 6, then what you say about the area of triangle GAB? And that G, DEF all are the usual notations. DEF are the midpoints of the sides, G is the centroid. Okay, and area of triangle DEF is given. That means this area is given. And area of triangle GAB is asked. Okay, and we need to find GAB. This area we need to find. So the question is from this triangle diagram to that diagram. And since DEF area is 6, every area is 6. Since every area is 6, area of the triangle is how much? 24. Okay, and since area of triangle is 24, now these three are equal. Okay, so you need to divide the 24 into three equal parts, and there you will get this area as 8, dividing the 24 by 8. So area of triangle GAB is simply 1/3 of the total triangle, and the area of the total triangle is simply 4 times of this DEF. On solvation you will get 8 as your answer. Okay, just have a look. Okay, and go for a screenshot. This is something related to the medians, midpoints and centroid based on the area of a triangle. So just look at the board, Apollonius Theorem, which we usually derive it based on Pythagoras Theorem. Okay, the proof of Apollonius theorem depends on the Pythagoras theorem. So we are all very familiar with the Pythagoras theorem. What it is? Hypotenuse square is equals to the sum of the squares of the other two sides in a right angle triangle. Using that, based on that, we will generate this Apollonius theorem. So, and what this Apollonius theorem says, and what is Apollonius theorem? Just have a look. So, for suppose if we have a triangle ABC, ABC is a triangle, okay, and D is the midpoint of BC. So, these two are equal, and that's why it is the midpoint. So, if you join AD, it is a median. So, there exist three medians in a triangle. You just now pay attention on one median AD. Okay, this is all the given part. So, if you have a triangle and if you have a median, then the role of Apollonius theorem enters. When it enters, after having a median in a triangle, then Apollonius theorem says that sum of the squares of the other two sides, other than this BC, two sides are there, right? AB, AC. So, AB square plus AC square is equals to 2 times of this median length, AD square plus BD. BD and CD are both are equal actually. So you may write BD or CD, so that BD square. So this is the statement of Apollonius theorem. And in this statement, AD means what? A to D is the median, and as per our notation, this is M1, right? So this Apollonius theorem helps us to find the length of the median, and I will calculate length of median in the next bit. Okay, and now you just learn the statement of Apollonius theorem. Very, very important. Okay, in coordinate geometry, in trigonometry, and properties of triangles, everywhere this Apollonius theorem helps. Okay, so Apollonius theorem is just if you have a triangle with the median AD, then sum of the other squares of the other two sides, AB square plus AC square is equals to 2 times of AD square plus BD square is the Apollonius theorem. Now we are going to find the length of the median using this Apollonius theorem. Okay, just look there how to find the length of the median. D, length of median. So there are three medians as I mentioned you. First of all, I will find the length of M1, and then similarly we will write the formula for M2 and M3 also. So my target is to find M1 now. So to find M1, see, in a triangle ABC, everything is in a triangle ABC. So if you have a triangle ABC, it is very clear that opposite to B, this is B. Opposite to C, this is C. And opposite to A, this total length is how much? A. So D is the midpoint. So this length is A by 2, this length is A by 2. So if you use the sides of the triangle as small a, small b, small c, it is C, it is B, it is A by 2, it is A by 2, and this median length is M1 as mentioned. Now you just use this Apollonius theorem for these numbers. So from Apollonius theorem, what we have? Just have a look. Yeah, this is Apollonius theorem. From Apollonius theorem, so AB square plus AC square. AB is small c, AC is small b. So C square plus B square is equals to 2 times of AD square. AD square is what? M1, median length. M1 square plus BD square. BD or CD are same as A by 2. So it's a square. So which is A square by 4. Just have a look. C square plus B square is equals to 2 times of M1 square plus A square by 4. So you just simplify it and make M1 as the subject, and that gives you the median length. So okay, C square plus B square is equals to 2M1 square plus A square by 2 if you multiply with 2. I need to find M1. So send A square by 2 this side and 2 also this side. So it is very clear that C square plus B square minus A square by 2 is equals to 2M1 square. Okay, and how we derived it? Just using Apollonius theorem, and this is Apollonius theorem. Okay, this is the diagram. From there we have that statement. Okay, I will erase it for the space concern, and I will calculate the M1. Okay, just I am erasing. Just have a look at the end. From Apollonius theorem we have that C square plus B square minus A square by 2 is equals to 2M1 square. Okay, so that implies 2M1 square is equals to, if you LCM in this side, 2c square plus 2b square minus a square by 2. Again, since I need m1 square, m1, so to this side. So that implies at the end m1 is equals to, directly I am writing, okay. After removing the square, you will get that m1 is equals to half of root of 2b square plus 2c square minus a square. This is m1. Once again, just have a look. m1, length of the median. Length of the median passing through the vertex A, and its length is root of 2b square plus 2c square minus a square. Similarly, you can find m2 also. Okay. Now, m2. What is m2 actually? m2 is the length of median through vertex B. L2 is length of median through vertex B. So since you are trying to find the length of median through vertex B, its length is given by symmetrical formula half square root of, since it is m2, vertex through B minus b square I need to write. So 2c square plus 2a square minus b square. So similarly we will write m3, length of the median through vertex C, and that m3 is half 2a square plus 2b square minus c square. At the end, leave all this derivation. You just pay attention and memorize these rules. m1, m2, similarly you may write for m3 also. These rules will directly help us to calculate the length of medians. Okay, just have a look. So at the end we have length of medians in a triangle. So the triangle is ABC. The sides of the triangle are small a, small b, small c. Using that small a, small b, small c, we will calculate median lengths, and those median lengths are m1, m2, m3. So m1 is half root 2b square plus 2c square by a, 2c square minus a square. m2 is this and m3 is this. Is it right? And in some questions, they may ask you to rewrite this median in some other words. How it is? So this is equals to half square root of, see, 2b square plus 2c square minus a square, right? I will write it like this. b square plus c square plus b square plus c square minus a square. Is there anything wrong? So nothing is wrong, okay. Just what I did? Just I did that. I wrote the 2b square as b square plus c square, and I wrote the 2c square as c square plus c square. Okay. And in the next step, this is equals to half root of b square plus c square. Okay. Then what you say about this b square plus c square minus a square? Once again I am repeating what you say about that b square plus c square minus a square. So that b square plus c square minus a square is nothing but 2bc cos a from cosine rule. Okay. So plus 2bc cos a. Is it right? Just analyze it. So median m1 is equals to half root of 2b square plus 2c square minus a square, and that is half root of b square plus c square plus b square plus c square minus a square. This b square plus c square minus a square is nothing but 2bc cos a from cosine rule. Okay. So these two are set. See, still there is something to simplify if they ask you. Okay. But at present, up to this it is enough to memorize. So median length is again equivalent with this half root of b square plus c square plus 2bc cos a also. Okay. Right. And the next part is, this is m1, this is m2, this is m3. Okay. This is one thing, and I will erase it. Or if you wish to simplify, what will happen? Further, if you wish to simplify, this is half root of b square plus c square. You just write plus 2bc and minus 2bc as per the necessity actually. Okay. Plus 2bc. Okay. Minus 2bc cos a. Plus 2bc minus 2bc plus 2bc cos a. Just I am adding one 2bc, okay. b square plus c square is there. I am adding just one 2bc, and that is 2bc cos a. And if you simplify, this is half root of this b square plus c square plus 2bc is nothing but b plus c whole square, and 2bc cos a and minus 2bc. From there, if you come out 2bc, you will get that cos a minus 1. And this cos a minus 1 again can be written as minus 2 sine square a by 2. Okay, minus 2 sine square a by 2. This is step by step simplification, okay? If you are facing an objective question, a more than one answer type or a single correct answer type, sometimes they ask you to find the median length, but among the options you won't find this one. You may find this as one of your option. Or sometimes on further simplification you may find this as your option, okay? So for that I am mentioning here. At the end the median length is this. Just you memorize it, that's enough. But if it is not there in the options, to arrive to the options, you need to simplify it further in such a manner, and that's why I mentioned it. Okay, just have a look, that's enough. But at the end, you need to memorize these three. Actually, not three, just one. If you memorize this M1 length, then automatically you will get an idea related to M2 and M3. Okay, this is just E bit, and I am erasing this, and I will give you F. Okay, is it clear? I am erasing. Yeah, then F. So we have M1, M2, M3. Median lengths already we found it. And if you square it, what will happen? What you say about M1 square? Squaring on both sides. So if M1 square is simply nothing but square root will get cancelled. 2b square plus 2c square minus a square by 4. 2 square. And the next term. M2 square. M2 square is 2c square plus 2a square minus b square by 4. Then M3 square. M3 square is equals to 2a square plus 2b square minus c square by 4. Just square on both sides. And after that squaring, you need to add these three. Now, just have a look. M1 square plus M2 square plus M3 square. And if you add these three terms, 1 by 4 is a common thing. So you just common out 1 by 4. And now in the bracket, directly you just simplify it, okay? Writing everything is bit lengthy. Just look there. Here it is 2b square. We are adding. Since we are adding these three, the denominator 1 by 4 is common, just write it out. Then you pay attention on the numerators. Here 2b square, and here 2b square, and here minus b square. And whereas if you think about a square, this is 2a square, this is 2a square, and here it is minus a square. 2a square plus 2a square is 4a square, minus a square is 3a square, plus 2b square plus 2b square is 4b square, minus b square is 3b square. And then 2c square plus 2c square is 4c square minus c square is plus 3c square. At the end, there is a chance to write 3 out. So this is 3 by 4 of a square plus b square plus c square. And m1 square plus m2 square plus m3 square is equals to 3 by 4 of a square plus b square plus c square. Very helpful. Sometimes they ask you, they will give you they won't give you a, b, c. Directly they give you the sum of the squares of the sides of the triangle as some 32. Then find the sum of the squares of the medians of the triangle. So sometimes they give you this a square plus b square plus c square as some 32, and they ask you to find this m square plus m2 square plus m3 square. Then you need to use this particular formula, and this is f. Just have a look, and all these things are related to the medians and length of medians. Okay, just have a look. As we discussed, median is the line segment joining vertex to the midpoint, and its point of there are three medians, and its point of congruency is centroid. And as we discussed, here we found that length of the median AD as m1. So from the diagram, AD is equals to m1, BE is equals to m2, and C of the third median is equals to m3. Okay, and AD is m1, and this AG by GD is 2:1 ratio. Already I mentioned you in the first point. Centroid divides median in the ratio 2:1. And since centroid divides median in the ratio 2:1, if this AG is 2 parts, this GD is 1 part, and that's why since AD is m1, from there it is very clear that what to say about AZ and ZD. Very important actually. So and that AZ and ZD is just nothing but 2 parts out of 3. So this is 2 by 3 m1, and this GD is nothing but 1 by 3 m1. Just have a look. this total length A to D, it is m1, and if you have a break at G, AG length is 2 by 3 m1 and this GD length is 1 by 3 m1. And similarly we have a chance to split this BE also into two parts. Okay, what are those? BG and GE. One is 2 by 3 m2 and the other is 1 by 3 m2. Again this CF also into two parts, CG and then GF. See, CG is equals to 2 by 3 m3 and GF is equals to 1 by 3 m3. Okay, because centroid is dividing the median in the ratio 2:1. Okay. Now you just pay attention on this triangle. I will show you here what is the triangle. A, G and then B. This triangle I am just separating you. What is the length of this AZ? 2 by 3 m1. What is the length of this BZ? 2 by 3 m2. And what is the length of this ABC? So 2 by 3 m1, 2 by 3 m2 and C. From this triangle, already I mentioned you in the last class, sum of two sides is greater than third side. Okay, in any triangle it happens, sum of two sides is greater than third side. If you use this particular logic for this triangle, if you take these two are the two sides and the C is the third side, sum of these two in the sense what will happen? 2 by 3 of m1 plus m2 is greater than C. Sum of these two is greater than C. And what you say about m1 plus m2? Now m1 plus m2 is greater than, if you send this 2 by 3 that side, 3 by 2 C. So at the end you have that m1 plus m2 is greater than 3 by 2 C. So therefore we will conclude that m1 plus m2 is greater than 3 by 2 C. Okay. Then what you say about m2 plus m3? What you say about m3 plus m1? Okay. The first thing is m1 plus m2 is greater than 3 by 2 times of C. m2 plus m3, since m1 is missing, so 3 by 2 times of A, and m1 plus m3, since m2 is missing, second one, 3 by 2 times of B. And now if you add all these things in the left side, 2m1, 2m2, 2m3, and in the right side 3 by 2 is a common number. Left side 2m1, 2m2, 2m3, right side 3 by 2 is a common number. From the left side 2m1, 2m2, 2m3, you just separate 2 and send it that side. From there it is very clear that m1 plus m2 plus m3, which is greater than 3 by 4 times of A plus B plus C. Okay, here I have no space there, that's why I mentioned like that. Okay, at the end, see in the previous point F, I mentioned you the sum of the squares of the median relates to the sum of the squares of the sides. Here in this point, sum of the direct lengths of the medians is greater than 3 by 4 times the sum of the lengths of the sides. Okay, everything you need to identify. Okay, just analyze it and try to memorize them. Okay, just have a look. Okay, at the end, that's for today's class. Just observe all those things. All these formulas and tricks related to the medians are very helpful in solving the problems. Okay, and in the next class we are going to solve some problems on medians based on these tricks and formulae, right?